atoms. For example, CO2, H2O, ammonia, etc. Okay.
Yeah.
So now we have to calculate what is atomicity for the molecule. So atomicity is the number of atoms present in a molecule. Okay. Present in a for example, in O2, atomicity will be 2. Okay. In H12, C12, H22, O11, the atomicity will be 12 plus 22 plus 11, 45. Okay. So question could be like, what is the atomicity of carbon here?
12.
Yes, it is 12. For hydrogen, it is 22, and for oxygen, it is 11. Okay.
Yeah.
Is it clear?
Yeah.
Okay. So we can say that if we have to convert molecule into atoms, then we have to multiply it with atomicity. Then we'll be able to know how many atoms are present in a molecule. And if we want to know what is molecule, then we have to divide with atomicity.
Yeah.
Okay. So we know in an atom, we have a symbol, atomic number, and atomic mass. And in atom, we talk about protons, electrons, and neutrons. Okay. So the charge, absolute charge on electron is minus 1.6 into 10 raised to the power 19 coulomb. In proton, it is 1.6 into 10 raised to the power 19 coulomb. Or on neutron, what is the charge on neutron?
0.
Yes, it is 0. Okay. So the relative charge on proton is on electron it is -1, on proton it is +1, and on neutron it is 0. Okay. The absolute mass on electron it is 9.1 into 10 raised to the power -31 kg. On proton it is 1.67 into 10 raised to the power 27 kg. On neutron it is 1.67 into 10 raised to the power 27 kg. So mass of proton is equal to mass of neutron.
Yeah.
We can say this. Okay. So if we talk about relative mass, so we write it as for neutron it is 1 AMU, atomic mass unit AMU. Okay. On proton also it is 1 AMU, and for electron it is around 0.
Yeah.
Okay. So we know that the mass of one atom is equal to the mass of proton into number of proton plus mass of neutron into number of neutron. Okay.
Yeah.
So number of neutron plus number of proton give us mass number. So we can say that mass number into mass into the mass of proton or the mass of neutron, because mass of proton is equal to mass of neutron.
Yeah.
Okay. So from here we can say that 1 AMU or 1 atomic mass unit is defined as 1/12 of mass of 1 carbon 12. So 1 AMU here is equal to, so mass of 12 carbon is 12. See. So what we have done here is mass of one atom is mass number into mass of proton. Okay. So from definition, AMU, 1 AMU is 1/12 of mass of carbon 12. Okay.
Yeah.
So mass of carbon 12 will be mass number into mass of proton. So it will be 1/12 into 12 mass number into mass of proton.
Yeah.
Is it clear?
Mm.
Okay. So from 12 will get cancelled out, and mass of proton. So 1 AMU is mass of proton, and that is what we have written here. That mass of proton is 1 AMU. Okay. So
Yeah.
1 AMU is nothing. It is mass of one atom. Okay. For example, I'll take example after this. So AMU is clear. So now we will talk about what is mole. Mole is defined as number of entities or particles present in 12 gram of carbon 12, and the value is 0.23 into 10 raised to the power 23 Na. We call it as Na, and the unit is per mole. Okay. So the 1 mole has 6.023 into 10 raised to the power 23 particles. Okay. Okay. Remember this relation. If we multiply Avogadro number with 1 AMU, then we will get 1 gram. Okay, remember this. So if we write oxygen 13, okay, and if I'm writing it as 6 AMU, 16 AMU, then it will mean it is mass of 1 atom. Okay, because AMU is for 1 atom, so 16 AMU is for mass of 1 atom. And if it is 16 gram, then it is mass of 1 mole of atom. Okay?
Yeah.
Okay, and AMU is nothing, it is mass of proton. Okay?
Yeah.
So let's do one question. According to new definition, 1 AMU is defined as 1/6 of mass of 1 atom of carbon 12. What will be the new value of AMU? Okay, so earlier the definition was 1 AMU is defined as 1/12 of mass of 1 carbon atom. So here the definition has been changed that 1 AMU is 1/6 of mass of 1 atom of carbon 12. So 1/6, what is mass of 1 atom of carbon 12? Is 12 into mass of proton. So the answer is 2 m mass of proton. Okay.
Yeah.
Earlier 1 AMU was equal to mass of proton. According to this question, it will be twice the mass of proton. Okay.
Yeah.
So now we will do some calculation for mole. So to calculate number of moles, the formula is, what is the formula for calculating number of moles?
Weight by atomic mass.
Yes, given mass upon molar. This is the first formula. Second formula is given particles, given number of particles divided by Avogadro number. Third formula is for number of atoms given mass in AMU divided by molar mass in AMU. Okay, these are
Yeah.
3 important formula. So from here we can say that it is very important. Remember this. Okay, if we have mass, if mass is given in grams, then we can find the moles. My first formula.
What?
If mass is given, then we can find moles.
Yeah.
Okay, and if moles are given, then we can find number of molecules by
Yeah.
multiplying it with Avogadro number.
Yeah.
Okay, and if we are able to calculate number of molecules, then if we multiply it with atomicity, then we will be able to get number of atoms.
Yeah.
It is very important. Okay, it's kind of short trick. Okay.
Yeah.
So now we will do one question, which is to calculate number of atoms for first 88 gram of CO2. Using this chart, you can calculate the number of atoms. Okay.
Yeah.
You can try. Don't solve Avogadro number, just write it as NA. Okay.
Okay. Six NA.
6, no, it is 4 NA. See, first you need to calculate number of moles, which is
Hmm.
88 by 44.
Yes.
Okay, which is 2 moles of CO2.
Yeah.
Or if we multiply it with Avogadro number, we will get number of molecules. So 2 into Avogadro number,
Mhm.
molecules of CO2.
Yeah.
And if we multiply it with atomicity, then we will get the number of atoms of CO2. And what is the atomicity here?
3.
Okay, 3. Okay, it was 6. Sorry. Yeah, it was right. Very good. Okay. So is it clear to you?
Yeah.
Very good. So next is 88 AMU of CO2. Anshul, you just need to
Yeah.
use this formula. Direct answer. So that is
Two.
2. Okay.
Is the answer 2?
Number of atoms. Yeah, of CO2 it is 2.
Okay.
It is in AMU. See, it is not in gram. So for AMU, we have this formula.
Yeah.
Okay. So just need to put the values and you'll get. Okay. So can you tell me number of atoms for oxygen in this?
What?
Number of atoms of oxygen in CO2.
It's 2 atoms.
We have
Equal.
in 88
Oh,
AMU.
88. Okay, it will be 4.
Yes, 4 and 4 carbon will be 2. Okay.
Yeah.
Okay. We can do one more question. Number of atoms in 0.1 mole of triatomic gas is
0.3 Na.
yes 0.3 Na. Very good. So now we will start with molar volume. So you must be aware of formula. Number of moles is equal to given volume divided by molar volume. है ना? So at 273 Kelvin and 1 atm, the value of molar volume is 22.4 liter. At 273 Kelvin and 1 bar, the value is 22.7 liter. And at 298 Kelvin and 1 atm, the value is 24.7 liter. Okay. Most of the question, in most of the questions, we use this value for molar volume. Okay. We will do a simple question. 2 gram of CO2 at, so this is at NTP. So at NTP, normal occupies the volume. Okay, you need to tell how much volume it occupies. 2 gram of oxygen.
Do we multiply number of moles with volume to at NTP?
What?
Do we multiply number of moles with volume at NTP to get the answer?
I guess you have to divide it.
Okay.
22.4 liter. What?
Was it 1.4?
Yes, it is 1.4 liter. Very good. Do you want me to solve it for you? Or is it clear?
No.
Okay. So now we will talk about ideal gas equation. Okay. So the ideal gas equation is PV is equal to nRT. Okay. So for that, write some of the units. Like for pressure, it is Pascal or Newton per meter square. SI units or mm or Hg, atm or bar. Okay, these are the units for pressure. For 1 atm, we have 160 mm of Hg, 1.013 bar or 1.013 into 10 raised to the power 5 Pascal or 760 torque. Okay.
Yeah.
Remember this. This will be very much helpful for you. So for volume, unit is 1 liter, which could be 10 raised to the power 3 centimeter, 1000 ml, and 1 dm cube. Okay. These are the units for volume. Next is for temperature. Kelvin. Okay.
Yeah.
It is degree Celsius in Kelvin. For universal gas constant, which is R, The values are 8.314 joule per Kelvin per mole or 0.0821 per liter ATM. It's not per liter, it is liter per liter ATM per mole per Kelvin or 2 calorie per mole per Kelvin. Okay. So you have to use the values of R according to the units given or asked in the question. Okay.
Yeah.
So the ideal gas equation is PV is equal to nRT. You must be aware of
Yeah.
this.
Yeah.
Okay. So if we can write it like this as well.
Yeah.
So N by V is number of moles divided by volume is
Molarity.
yes concentration. Okay. So we can write this equation that P is equal to CRT and also that P is equal to nRT, and we can write PV is equal to N number of moles will be weight divided by molar RT. So if we take molar mass over here and volume in denominator, then we can write it like this.
Yeah.
So weight upon volume is weight or mass upon volume is density.
Yeah.
So we can write pressure into molar mass is equal to density RT. This is also another formula we can use.
Yeah.
Okay. So there is one more formula. Vapor density is equal to molar mass of gas divided by 2. Okay. Remember this formula? Okay. So we will do one question.
Yeah.
The vapor density of gas A is twice that of a gas B if the molecular weight of B is m, the molecular weight of A will be
Maybe 2m.
yes, it is 2m. Very good. You are very intelligent. So there is one more formula for finding average atomic mass of an element having isotopes. Okay. So if we have an X element which have 3 isotopes, one is this, second is of 25, and third is of 30, and their percentage of abundance is 30, 30 and 35. Then if we have to find the average atomic mass of that element, it will be sum of atomic mass into percentage abundance divided by 100. Okay. For this,
Yeah.
the atomic mass for first is 20 and its abundance is 30. So plus for second is it is 25 into 30 plus 30 into 35 divided by 100. Solving this, you will get the average atomic mass of an element having isotopes. Okay, that will be 25.5. Okay. So till now we have done atomicity, what is AMU, Avogadro number, how we can calculate number of atoms, molecules, number of moles, then ideal gas equation, 3 equations associated with it. So now we will start with empirical formula. Do you know what is empirical formula?
Like a
Simplest number of atom present in a
simple.
compound. Okay. And molecular formula tells about the exact number of atom of each element present in one molecule or one compound. So we have one formula which is molar mass or molar formula is equal to n of empirical formula or mass. This is the relationship between empirical formula and molecular formula. So now we will start how to calculate empirical formula. For that, we have to make a table. In first column, we will write the elements. For example, we have carbon, hydrogen, oxygen, and nitrogen given in the question. In second, we will have ratio of atomic mass. Okay. And the next will be simplest whole number. So ratio of, it will be a bit confusing. It will be given mass divided by molar mass or atomic mass. Okay. Let's say for carbon, given mass is for 24, for hydrogen is 16, for oxygen is 32, and for nitrogen is 28. So now we have to calculate the empirical formula for this. Okay. So the first column, we will write all the elements which are given in the question. Then they're given mass. And now we have to divide it with molar mass. Molar mass, atomic mass of carbon is 12, hydrogen is 1, oxygen is 16, and nitrogen is 14. Okay. So it is 2, 16, 2, and 2. Now we will make it simplest. Okay. So for that, just divide it with this lowest number. Okay. So divide 2 by 2, 16 by 2, 2 by 2, and 2 by 2. We will get 1, 8, 1, and 1. Okay. So now write the corresponding formula for it. Like for carbon, we have 1. This will be empirical formula. Okay. So carbon is 1, 1. Hydrogen is 8, H8. Oxygen is 1, oxygen 1. Nitrogen is also. So this is the empirical formula. Okay. So we will do one question. Is it clear to you? Like first you have to write the elements given, then is it clear?
Yeah.
Given mass by molar mass, then simplest value.
Yeah.
Okay. The question is, an organic compound contains 78% and remaining percentage of hydrogen. So empirical formula will be, okay, you have to calculate the empirical formula. So first write the elements. It is, okay, this carbon, of carbon. I just missed it. Carbon, and second one is hydrogen. If it is coming in decimal, then round it to the closest number. Okay.
It's CH3.
Yes, it's CH3. Very good. It is CH3. I will send you more questions, okay, of this topic. So now we will start with stoichiometry. Okay, so let's say we have a chemical reaction. This. Can you balance it?
It will just be 2O2.
Yes, 2O2 and 2H2O. Just wait for a second. My laptop got hang. Okay, just wait. Okay, so let's say we have this equation. So from this equation, we can have so many information, like just with this stoichiometry. So from just looking at this, we can say 1 molecule of methane is reacting with 2 molecule of oxygen to give 1 molecule of CO2 and 2 molecules of H2. Okay, and we can also write it as, if we divide it with Avogadro number, then we will get 1 mole of methane is reacting with 2 mole of oxygen, giving us 1 mole of CO2 and 2 mole of H2.
Yeah.
So the weight of 1 mole of methane gas is, you can calculate.
16.
Yeah. So we can say that 16 gram of methane gas is reacting with 64 gram of oxygen, giving us 44 gram of CO2 and 36 gram of H2. Okay. Is it clear to you how I have written this?
Yeah.
Okay. And so these are the information we can just write by seeing the equation. And now I will give you one trick for calculating, for doing the questions related to it. So the first question is mass of oxygen required and moles of H2O and volume of CO2 to produce if 10 gram of methane is burned. Okay, so just write, first of all, write the equation. So methane is burned, the presence of oxygen giving us CO2 plus 2H2O. Okay, so first write the standard values. Like from this stoichiometry, the information we can get, just write that. Like for standard values, methane will be of 16 gram and oxygen will be of 64 grams. So now write what is given and what is asked. So given is 10 gram of methane. Okay,
Yeah.
right, 10 gram here. And what is asked? Asked is mass of CO2. Sorry, mass of O2 required. So we have to find this volume of CO2 in liter and moles of H2O. Is it clear? Like this is what given. 10 gram is given. Weight of oxygen is asked. Volume of CO2 is asked, and moles of H2O also has been asked. Okay. So the standard mass of methane is 16 gram. Standard mass of CO2 oxygen is 64 grams, and for standard volume of CO2 will be 22.4 liter. 1 mole 22.4 liter, and the number of moles of H2O standard will be 2 moles. Okay. Okay. So now we have to find the mass of oxygen. What is the mass of oxygen produced? So for that, what you will do first, multiply the given with the standard. Okay. Multiply 10 by 64 and then divided with this.
Yeah.
16. The answer will be 40 gram. Okay. So this is trick. Okay.
Yeah.
So just write first standard, then given, then multiply the given with the standard and divide it with the standard. Then we will get the answer. This is 40 gram. Now, volume of
For
CO2.
volume, I got 11.4.
11.4.
liter.
Okay, let's see. So for volume of CO2, we will again multiply it with the standard, which is 10 into 22.4, and then again divided with 16. Did you
Okay.
solve this?
Um, 14.
So, yeah, the answer will be 14 liters. Okay. So the next is to calculate moles of H2O. Use the same trick. You will get the answer.
1.25.
Yes, 1.25. Very good. So it's very simple. You just need to first write the standard values, then the given values, cross multiply and divide. You will get the answer. Okay. Now we will do one more question. For 100 gram of H2O formation, calculate moles of H2 required and volume of O2 required. Okay. So first we will write the equation, which is H2 plus O2 give 2H2O. So the standard is, so what is asked? Moles of H2, volume of O2, and the given is 100 grams of H2O. The standard will be 2 moles, 22.4 liters, and 36 gram. Okay. So now for the volume of O2, we will do first we will multiply it with 22.4, 100 into 22.4. Then we will divide it with 36. We will get the answer. Okay, so it is 60.2 liters.
Yeah.
Then we have to calculate the moles of H2. For this, we will again multiply 100 by 2 and then again divided by 36. The answer will be 5.5.
Yeah.
Okay, is it clear?
Yeah.
So now we will do the another question. How many grams of H3PO4 is required to complete neutralize 120 gram of NaOH? First write the equation plus H2O. First balance it.
Yeah, I'm done with the balancing.
It is?
Wait, I'll balance it. And ma'am, won't it be any 3PO4 compound?
Yes, it will be 93. Sorry. Sorry. Very good. You are very intelligent.
No, maybe 98 grams.
Yes, it is 98 grams. Very good. So one more question. What weight of SO2 can be made by burning S in 5 moles of O2? So sulfur plus O2 is giving SO2.
With 320 grams.
Yes, it is 320 grams. Very good. So now we will start with purity concept. In this, we do not have to take the given mass of reactant. Same in the question. Okay. Same as question. Okay. So it will be more clear with the help of a question. A sample of 300 gram of CaCO3, 90% of purities. Okay. Is decomposed. Calculate the volume of CO2 released. So in these type of question, where purity is given, there we do not have to take exact weight of exact gram of the reactant because there is some impurity in it. Okay. So let's first write the equation. Limestone is burnt. Then we will get this. Okay. So first we will write given. So it won't be 300. Okay. It won't be 300 because there is some impurity in it. So 90% impurity, 90% purity means now convert it. We have to convert it
270.
Yes. So this is the mass of reactant. Okay. So the 30 gram was the impurities in it.
Yeah.
So what is asked? Calculate the volume of CO2. So now we will write standard. In standard, the molecular mass of CO3 will be 100 grams. Okay. And C for CO2 will be 2.4 liters. Okay.
Yeah.
Now we will cross multiply given with the standard and then divided with this. We will simply get the volume of CO2, which is 270 into 22.4 divided by 100, which will be around
60.4.
0.4.
Yeah.
Yeah, 60.4. 60 or 6.04.
Hmm.
60.48. So my laptop has restarted. So I was restarting it. So now we will go for yield concept. So in some questions, the yield is asked. So the formula for yield is actual yield divided by theoretical yield into 100. Okay. So the actual will be given and the theoretical we have to calculate that this much will, like this much should be produced. So let's do one question. Carbon plus oxygen give CO2 with 50% of efficiency. If 20 gram of carbon is burnt, calculate the volume of CO2 produced. So first we will write the equation, then standard 12 gram, 22.4 liter.
Will be 22 grams.
Yes. So now we will start with limiting reagents. Okay, 10 minutes are left. So limiting reagent is the reagent which gets consumed first and decides the product. Okay. So to determine which is limiting reagent, there is a one trick, that is just divide given number of moles by stoichiometry. Okay. Whosoever value is less, that will be the limiting reagent. For example, if we have A plus 2B giving us 5C and it is given the moles of A is 10 and the moles of B is also 10. So now we have to know which is limiting reagent. Just divide the given mole. For A it is 10 by 1 and for B it is 10 by 2. So it is 5 for B. So this value is less than 10. So B is the limiting reagent. Okay. Let's do one question. If 0.5 mole of BaCl2 is mixed with 0.2 mole of Na3PO4, the maximum number of moles of Ba3PO4 2 will be. First, write the equation. First, balance this equation.
it will be 3 BaCl2
Hmm.
plus 2 Na3PO4
Mhm.
gives this is just 1 BaCl2 twice plus 6 NaCl.
Yes, very good. So now we will determine which is the limiting reagent here. So given number of moles are for BaCl is 0.5. For Na3PO4 it is 0.2. Okay, so we will use the trick. So 0.5 divided by 3 and 0.2 divided by 2. Given moles divided by stoichiometry. Okay, so the value will be 1.6 and for this will be 0.1. So this is smaller. So we can say Na3PO4 is limiting reagent here. Okay.
Yeah.
So now we have to calculate number of moles of BaCl, this Ba3PO4 whole twice is produced.
For BaCl2 it's 0.2, 0.16.
1. Yes, it is 0.1. Very good. Okay. So just wait for a sec. Let me go. Is it clear till now?
Yeah.
Real concept, limiting reagent, how we are determining it.
Yeah.
Okay. Sorry. Now we will start with the concentration term. So these concentration terms are divided into two parts. First one is volume based. Second one is mass based. Okay. So the volume based are the ones which are temperature dependent. How it is temperature dependent? Can you tell me?
Increase in temperature increases the volume.
Yes, the temperature increases. Yes, it is directly proportional. And what about mass?
It's not dependent on temperature.
Yes, it is temperature independent. So volume based, we study about volume by volume percent, weight by volume percent, molarity, and normality. Okay. The mass dependents are weight by weight percentage, molality, we denote it as small m, and for molarity it is capital L. Okay. So we will study about them one by one in next class. Okay. And today I will send you topic wise questions, the topics which we have covered today. Okay. And if you have any doubt, you can ask me.
No.
Okay. So tomorrow we will complete concentration terms and PYQs along with some laws. Okay.
Yeah.
Okay. So that's all for today.
Yeah.
Thank you.
Thank you.